Welcome to this expert technical training module. Today we focus on identifying the right AI model based on its specific capabilities and your application requirements. Welcome everyone to this expert level training session. Today, we are focusing deeply on a highly critical architectural decision in artificial intelligence, identifying and selecting the appropriate AI model based entirely on its operational capabilities. When we look at the landscape of modern AI, we are primarily dealing with foundation models. These are incredibly large, pre-trained machine learning models, such as GPT, Claude, and Mistral, that provide general language, reasoning, or multimodal capabilities right out of the box. However, not all models are created equal, and choosing the wrong one can lead to performance bottlenecks or massive cost overruns. As a solutions architect, you must understand the core distinction between large language models, commonly referred to as LLMs, and small language models, known as SLMs. LLMs feature vast vocabularies and massive parameter counts, making them exceptionally powerful for complex, generalized tasks, deep reasoning, and extensive generative AI workflows. But they can be costly and highly compute-intensive. On the other hand, SLMs are highly optimized, compact models that excel in specific, focused topic areas, or when you need to deploy an agent locally on a device with strictly limited computational resources. Choosing the correct model type is the absolute first step in building a scalable, efficient, and cost-effective AI application. Throughout this comprehensive module, we will systematically explore the different families of models available within Microsoft Foundry. We will break down their specific, technical capabilities, ranging from advanced natural language processing and coding generation, to multimodal vision, speech synthesis, and video creation. We will also learn exactly how to leverage the Foundry Model Catalog to meticulously benchmark, evaluate, and select the perfect AI engine to power your enterprise solutions. By strictly mapping capabilities to business requirements, we ensure architectural success. Let us dive in and master the foundational task of intelligent model selection. While there is no specific code to execute for conceptual model selection, the architectural choices you make here will directly impact how you initialize your API clients later. Selecting an LLM over an SLM dictates the specific endpoint URL and target deployment name you will ultimately hardcode into your backend application logic. Take a look at the flowchart on your screen. When your primary requirement involves natural language processing, you must carefully evaluate the specific text and reasoning capabilities of the available foundation models. In the Microsoft Foundry Model Catalog, we see several prominent model families tailored for distinct language tasks. For example, if your application demands highly complex, multi-step reasoning, structured logic, and advanced agentic workflows, the GPT-5.x family is an exceptional architectural choice. It excels in generating technical reports and orchestrating multi-tool agents, offering adjustable thinking levels so developers can deliberately trade computational speed for maximum accuracy. If you require a frontier-level model with massive context windows for processing exceptionally long specifications or multi-file code diffs, Anthropic's Claude Opus 4.5 is described as highly intelligent and phenomenally capable. Conversely, if your enterprise needs a general-purpose model that perfectly balances cost, performance, and efficiency, Mistral Large 3 offers a state-of-the-art alternative for multilingual drafting and structured business report generation. For extremely high-volume, real-time chat applications where low latency is more critical than deep, multi-step reasoning, standard models like GPT 4.1 remain highly optimized for speed. As an AI architect, you must match the model's documented strengths directly to your workload. You do not always need the largest, most expensive reasoning model if your application simply categorizes incoming customer support tickets or extracts basic key phrases from short text. Precision in this matching process ensures optimal performance and strict budget efficiency. Furthermore, for tasks requiring grounding in private enterprise data, you must ensure the model you select responds well to retrieval augmented generation, or RAG, architectures, seamlessly integrating retrieved knowledge chunks into its context window. In your client application, invoking a specific reasoning model requires matching the deployment string to the model you selected. If you deploy a Mistral model for efficiency, your Python code using the Azure SDK must explicitly pass that specific Mistral deployment name in the model parameter of the completions request to successfully route the inference. This diagram illustrates the decision matrix for text-based NLP workloads. Depending on the task type, developers route requirements to specific models. GPT-5. Moving beyond pure text analysis, modern enterprise solutions increasingly require models that can simultaneously process multiple types of unstructured data. These are known as multimodal models. A multimodal model can understand and work with text, images, and sometimes even audio concurrently. This incredible capability drastically reduces the need for separate, complex computer vision pipelines. When evaluating models for visual tasks, look for vision-enabled GPT models in the Foundry catalog. Models like GPT 4.1, GPT 4.1 Mini, and the highly advanced GPT-5 series are specifically designed for flexible, general-purpose visual reasoning. These models can take an image, such as a complex financial chart, a scanned document containing optical character recognition data, or a photograph of a physical object, along with a natural language text prompt, and generate a highly accurate text response describing or analyzing that specific image. For example, a multimodal model can extract the semantic meaning from a graph, analyze a dense architectural diagram, or answer direct questions about the objects interacting within a physical scene. When selecting a model for a customer support application that analyzes user-submitted photos, or an automated agent that reviews user interface screenshots for quality assurance, ensuring the model possesses native multimodal capabilities is absolutely essential. By leveraging these models through the OpenAI Responses API, developers can securely pass both the system text instructions and the base 64 encoded image data in a single, unified HTTP request. This approach greatly simplifies the underlying application architecture, removes the need for chained legacy models, and delivers profoundly intelligent, context-aware visual insights directly to the end user in real time. Selecting a multimodal architecture is a definitive step toward building truly perceptive, human-like AI agents. To query a multimodal model programmatically, developers format the API payload to include a content array. Instead of passing just a simple text string, the code passes an array containing both a text object and an image_URL object, which houses the base 64 encoded binary representation of the image being analyzed. Observe the multimodal processing workflow on your screen. When a user request includes both text and image data, the architecture routes it to multimodal processing. While reasoning and multimodal analysis are critical for comprehension, some applications demand specialized capabilities, such as media generation or advanced speech processing. If your requirement is to generate entirely new, original visual content from text descriptions, you must select a dedicated image or video generation model. Microsoft Foundry provides the GPT Image 1 family for this exact purpose. For enterprise-grade, high-fidelity image creation and precise visual editing, GPT Image 1.5 is the recommended choice due to its strong prompt alignment. For video generation, the Sora models, including Sora 1 and Sora 2, allow developers to create short video clips from text prompts or static images. These media generation tasks are highly compute-intensive and typically run as asynchronous background jobs via the REST API. Alternatively, if your application requires voice interaction, you must identify models capable of speech recognition and synthesis. Azure Speech provides highly specialized endpoints for converting spoken audio into text, utilizing complex acoustic and language models, and text-to-speech vocoders that synthesize natural-sounding prosody and inflection. On the opposite end of the spectrum, if your goal is to build a retrieval-augmented generation architecture, you need models capable of generating embeddings. Embedding models, such as Text Embedding 3 Small, do not generate human-readable text. Instead, they convert natural language tokens into dense, multidimensional mathematical vectors. These vectors perfectly map the semantic relationships between words, enabling your application to perform incredibly fast and accurate semantic searches. Identifying these specialized capabilities is a fundamental skill for AI engineers. By correctly identifying the need for generation, speech, or embedding models, you architect a complete, robust enterprise solution that handles diverse user inputs seamlessly. Integrating these specialized models requires utilizing distinct SDK methods. For image generation, developers call the images.generate method. For embeddings, developers call the embeddings.create method, capturing the massive float array returned in the JSON payload to immediately index it within a vector database for future semantic queries. This diagram breaks down the routing for specialized AI requirements. With thousands of distinct models available, how do you practically identify and select the exact right one for your specific architectural needs? The definitive answer lies in the Microsoft Foundry Model Catalog. The Model Catalog is a central, unified hub designed explicitly for discovering, evaluating, and deploying generative AI models from an extensive range of providers, including Microsoft, Anthropic, Mistral, Meta, and Hugging Face. As an enterprise architect, you never have to guess which model fits your needs. The catalog provides robust, granular filtering tools. You can filter the vast array of models by collection, foundational capabilities, supported inference tasks, such as conversational chat, text summarization, or code generation, and even industry-specific tuning for domains like healthcare or finance. Crucially, before finalizing any model selection, you must rigorously review the associated model card. A model card is a standardized, highly detailed document that provides absolute transparency regarding a model's capabilities, its intended use cases, and, most importantly, its constraints and known caveats. It explicitly outlines the model's limitations, responsible AI considerations, and boundary behaviors under stress. By thoroughly analyzing these model cards, you guarantee that your selected model adheres strictly to your organization's ethical guidelines and technical compliance requirements. The Foundry portal empowers you to compare these capabilities side by side, evaluating critical factors like context window size, licensing restrictions, and regional Azure data center availability. Mastering the navigation and analysis of the model catalog is an absolutely essential skill for building scalable, secure, and responsible enterprise AI ecosystems. Selecting a model without reviewing its model card is an architectural anti-pattern that introduces massive systemic risk to your production environment. While the model catalog is primarily an architectural discovery tool accessed via the web portal, you can document your model choice directly in your infrastructure as code repositories. When defining your bicep templates, include the specific foundational model ID referenced in the catalog to enforce version control on the AI resources deployed to Azure. This visual demonstrates the structured workflow within the Foundry model catalog. Selecting a model based on its documented capabilities is only the first phase of the engineering process. You must also empirically validate its performance against your specific enterprise workload. Microsoft Foundry simplifies this vital process through built-in benchmarking and comprehensive evaluation tools. Within the model catalog, you can access global model leaderboards, which rank models based on standardized attributes like quality, safety, and throughput for specific tasks like complex reasoning or code generation. However, to truly verify a model's specific capability, you should utilize the Foundry Playground to test it interactively with your own custom data, system prompts, and edge case scenarios. For a much more rigorous quantitative analysis, Foundry provides robust automated evaluators. These evaluators allow developers to score a model's raw output using classic natural language processing metrics, such as accuracy, precision, recall, and F1 scores. More importantly, you can utilize advanced, AI-assisted quality metrics to mathematically measure nuanced conversational characteristics like groundedness, relevance, coherence, and fluency. Groundedness is particularly critical in retrieval-augmented generation scenarios, to ensure the model's answers are strictly based on the provided corporate source data and not hallucinated from its base training weights. Furthermore, dedicated safety evaluators actively scan the model's output for harmful content, inherent bias, and protected class harms. By utilizing these data-driven evaluation techniques, you replace subjective human guesswork with transparent, mathematical proof that the selected model possesses the exact capabilities and safety guardrails required for your live production environment. To execute automated evaluations programmatically, developers utilize the Foundry Evaluator APIs in their CI/CD pipelines. The script loops through hundreds of golden test prompts, invokes the newly selected model, and captures the responses. These responses are then mathematically scored against a predefined threshold, automatically failing the deployment build if groundedness or safety metrics drop. The diagram displays the continuous evaluation pipeline. The selected foundation model is processed by Foundry evaluators, splitting into NLP quality metrics and AI-assisted metrics. Once you have successfully identified, rigorously evaluated, and mathematically validated the appropriate AI model based on its capabilities, the final architectural step is production deployment. In Microsoft Foundry, deploying a model takes that raw computational intelligence and transforms it into a stable, scalable, and highly secure API endpoint that your client applications and AI agents can securely interact with. During the deployment configuration phase, you establish critical operational parameters to perfectly match your enterprise infrastructure needs. You must select the specific deployment type, such as standard for typical synchronous workloads, global batch for large-scale asynchronous data processing, or regional provisioned throughput for guaranteed, dedicated performance in high-demand environments. You will also define strict tokens per minute, or TPM, rate limits to actively manage computational costs and prevent runaway API usage. Once deployed, the model resides safely behind Azure's formidable security boundaries, accessed via the OpenAI Responses API using secure managed identities or Azure Key Vault credentials. By systematically matching model capabilities to business requirements, evaluating performance, and configuring secure deployments, you guarantee the success of your AI initiatives. Understanding the capabilities of your chosen model ensures that your client applications deliver fast, reliable, and highly contextual responses to your users every single time. Thank you for joining this expert technical deep dive on identifying AI model capabilities. Please be sure to like this video, subscribe to our channel, and visit quicktechie.com for premium certification prep. At QuickTechie, we offer extensive Q&A banks, ebooks, audiobooks, advanced training modules, and expert interview guides to help you master Azure AI engineering. Keep learning and build intelligently. The final codebase implementation involves writing the client connection logic. Using the official Python SDK, your code retrieves the endpoint URI and Entra ID credentials securely. It then instantiates the OpenAI client object, passing the specific, newly deployed model name string into the completions.create function to initiate the inference process over the cloud. Our final diagram illustrates the deployment lifecycle. Taking the validated AI model, developers configure deployment parameters by setting TPM limits and selecting the deployment type.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.